At some point, the number stops sounding real. 200,000 miles still feels impressive. 300,000 sounds rare. 500,000 begins to feel like mechanical folklore. But then you find an old truck with 700,000 on the odometer, still starting on cold mornings. Or a workhorse sedan that crossed the country so many times its seats collapsed before its engine did. Or a taxi motor that idled through years of traffic, heat, dust, bad fuel, late oil changes, and human neglect, and kept going anyway. That is when you realize you are no longer talking about transportation. You are talking about endurance. Today on Timeless Treasures, we're stepping into one of the most respected corners of American machine history. The engines that earned a reputation for refusing to die, not because they were the most exotic, not because they were the fastest, but because they were built with a kind of seriousness that modern engineering rarely even attempts. Thick castings, conservative tuning, generous tolerances where it mattered, precision where it counted, and a philosophy that placed durability above fashion. This is the story of million-mile iron. And to understand why some American engines became legends of endurance, we have to start by rejecting a modern habit. Today, when people talk about engines, they often begin with numbers that look good in brochures. Horsepower, torque peaks, fuel economy targets, emissions packaging, software strategy, packaging efficiency, lightweight materials, thermal management systems. All of it important, all of it real. But durability does not begin with marketing numbers. Durability begins with intention. The most indestructible engines in American history were not accidents. They were not magically lucky combinations of parts. They were the result of design cultures that expected engines to work under punishment. In trucks, in fleets, in rural service, in taxis, on highways, in heat, under load, with inconsistent maintenance, and often in the hands of owners who treated mechanical sympathy as an optional philosophy. Those engines survived because they were built for a world that was harder on machinery. And that world shaped every decision. First, let's talk about what makes an engine truly durable. Not just reliable for a few years, durable over absurd time. A long-life engine usually shares a recognizable pattern. It is not chasing the edge of its own capability. It is not squeezing every last dramatic number from its architecture. It tends to use a strong bottom end, conservative internal stresses, robust cooling, oiling systems with enough margin, and materials chosen for real service life rather than spreadsheet elegance. In simpler terms, the best durable engines are usually underworked for what they are. They are strong enough that normal life feels easy. That is the first secret behind million-mile iron. The second secret is heat. Heat destroys engines more faithfully than almost anything else. Not instantly usually, quietly, gradually. It bakes seals, thins oil, warps surfaces, punishes bearings, weakens gaskets, and accelerates every bad condition already waiting inside the block. A legendary engine is almost always an engine that manages heat well, even if the driver never thinks about it. The third secret is speed, not road speed, engine speed. Many of America's longest-lived engines built their reputations not by spinning high, but by working in a slower, deeper, calmer part of the rev range. They made useful torque without needing to scream. They lived in broad, comfortable power bands. That matters because every extra revolution is another act of friction, another cycle of heat, another microscopic wear event added to the machine's life. A lower stressed engine can seem less exciting on paper, but paper does not survive 300,000 miles. Metal does. Now, once you understand those principles, a pattern begins to appear in American engine history. The great long-life engines often came from periods and sectors where engineers assumed the machine would be kept, repaired, loaded, and worked. That meant trucks, fleet vehicles, large displacement passenger engines from eras before hyper-optimization, industrially minded designs where serviceability and ruggedness mattered almost as much as performance. This is why so many American durability legends are not glamorous. They are truck engines, utility engines, police package engines, taxis, farm haulers, work vans, pickup motors with grease under their fingernails. And that makes them even more admirable, because true mechanical greatness often arrives without ceremony. Take cast iron. Modern engineering treats mass as a problem to be solved. That is understandable. Less weight can mean better economy, sharper handling, improved packaging, lower emissions. But cast iron carried one quality engineers and owners respected for generations: confidence. It is rigid, stable, resistant to certain kinds of abuse. It tolerates heat cycling well when properly designed. It can be machined, rebuilt, bored, resurfaced, and returned to life after immense use. A cast iron block or head may not win a weight comparison, but in the long war of mileage, it often proves why mass can be a form of mercy. Many of America's most indestructible engines carried that mercy in their bones. Now add displacement. A bigger engine making modest power often lives a surprisingly easy life. If a large, naturally aspirated engine produces its torque with little strain, then every internal component is being asked to do less violent work than a smaller engine forced to deliver the same real-world load under higher stress. This is one reason older American V8 engines earned such stubborn reputations. They were not always efficient, not always refined, not always elegant in their use of fuel, but many of them made everyday power without feeling pressed. They were not trying to prove anything every time you touched the throttle. They were simply doing the job. And that job usually happened far below the engine's absolute mechanical limit. That distinction matters more than people realize. A great many legendary American engines were designed in an era when the expectation of ownership was different. Engines were not necessarily seen as sealed lifetime units to be replaced by the vehicle's disposal. They were parts of larger mechanical systems expected to be maintained, repaired, and sometimes rebuilt. That shaped architecture. Fasteners, oiling passages, cylinder wall thickness, accessory placement, and internal margin all reflected a world in which longevity was not a romantic fantasy. It was part of the assignment. Now, this does not mean every old American engine was automatically durable. Far from it. Some were fragile, some badly cooled, some poorly assembled, some compromised by emissions-era confusion, some undone by carburation, poor metallurgy, or rushed development. We should not flatten history into myth. But when American engineering got durability right, it got it with a kind of industrial force that still feels impressive today. Think of the engines that became legends, not because collectors worshiped them, but because workers trusted them. Inline sixes that seemed unable to understand the concept of surrender. Truck V8s that spent decades hauling trailers, boats, masonry, livestock, tools, families, and every form of American burden imaginable. Diesel blocks, built so stoutly that owners spoke of them the way sailors speak of weathered ships. Police package and taxi spec engines that survived endless idling, heat soak, stop-and-go punishment, and brutal duty cycles without asking for much beyond oil, cooling, and respect. Those engines became famous the old-fashioned way, by outlasting witness after witness. And that brings us to one of the most important truths in all of mechanical storytelling. Durability is cultural. An engine becomes legendary, not only because it survives, but because enough people see it survive often enough to stop being surprised. At first, it is one story. Then it becomes a pattern. Then a mechanic says, "Those things just keep going." Then fleet owners start preferring it. Then rural communities begin to trust it. Then enthusiasts begin chasing it years after production ends because they have heard too many stories to ignore. That is how engines move from specification sheets into folklore. and American folklore loves an engine that refuses to quit. There is also something deeply national about this particular form of admiration. America has always carried a strange respect for mechanical stamina. Not just beauty, not just luxury, not just speed, stamina. The ability to keep working. The ability to remain useful under pressure. The ability to absorb punishment and continue performing. That respect shows up everywhere in American machine culture. In locomotives, heavy trucks, tractors, industrial equipment, work boots, hand tools, and of course, engines. The machine that lasts becomes more than a machine. It becomes moral. It becomes a symbol of seriousness, discipline, and hard use survived honestly. That is why million-mile engines carry emotional weight beyond engineering. They feel honorable. Now let's talk about what usually kills an engine before its time. Poor lubrication, cooling failure, detonation, contaminated fuel, overheating, neglected oil changes, bad sealing, weak bottom end design, over-revving, thin margins, poor machining, and perhaps most of all, the modern obsession with doing too much with too little. An engine pushed closer to its thermal, structural, or efficiency limits may perform brilliantly in the short term. It may be cleaner, lighter, more powerful per liter, and more sophisticated. But sophistication is not the same as longevity. When an engine is optimized to the edge, its margin for abuse shrinks. It may be excellent under ideal conditions and disciplined ownership, but legends are not built under ideal conditions. Legends are built when ownership is messy. The most indestructible American engines were often built with enough reserve strength that messy ownership did not kill them immediately. Late oil change, it survives. Heavy towing in summer, it complains less than expected. Bad fuel, it adjusts, coughs, and carries on. Long idle hours, it wears, yes, but not catastrophically. It accepts the reality that real life is imperfect. That acceptance is a form of engineering humility. It says the machine must be stronger than the human using it. And that may be the deepest secret of million-mile iron. Now look at design simplicity. A simple engine is not always the best engine, but simplicity has one major advantage: fewer things to fail, fewer hidden dependencies, fewer complicated interactions between systems that can collapse into expensive chaos. When the layout is legible, the maintenance tends to be easier. When the maintenance is easier, it gets done more often. When it gets done more often, the engine survives longer. This sounds obvious, but it matters. Some of America's longest-lived engines earned their reputations not only because they were robust, but because they were understandable. Mechanics knew them. Owners understood them. Parts were available. Repair paths were familiar. The engine remained part of a living mechanical culture, rather than becoming an encrypted system dependent on rare equipment and software rituals. That availability of understanding is part of longevity too, because an engine cannot survive if no one can afford to care for it. This is one reason old truck engines so often dominate durability conversations. Trucks live hard lives, but they also exist in ecosystems of maintenance. Owners check fluids. Mechanics know weak points. Fleets track failures. Aftermarket support stays alive. Rebuild culture remains active. And the engine continues because the surrounding human world keeps it going. A legendary engine is never only metal. It is also a maintenance civilization built around that metal. Now, we should also admit something less romantic. Some engines earn million-mile reputations because they are given the right kind of driving life. Long highway miles, steady oil temperature, lower cold start frequency, fewer short trips, fewer hard heat cycles. A commuter vehicle abused in city traffic may die younger than a workhorse that spends its life at stable load on open road. Mileage alone is not a perfect measure of suffering. But even when that is true, the reputation still has to be earned. Because plenty of engines enjoy favorable conditions and still never become legends. The American engines that did become legends usually had another quality: rebuildability. This is crucial. A machine built seriously is often a machine built with the possibility of renewal. Cylinder walls thick enough to machine, bottom ends worth saving, heads worth resurfacing. Enough aftermarket support to justify effort. The engine does not vanish the first time it wears. It returns. And that matters philosophically. Because a truly durable engine is not only one that lasts a long time untouched, it is one that deserves another life when the first one finally ends. That idea has largely faded from mainstream car culture. Many modern powertrains are astonishing in capability, but not always lovable in that old industrial sense. They can be brilliant, efficient, and fast, while still feeling temporary, replaceable, sealed, too integrated to be worth preserving once major problems arrive. Million-mile iron belongs to another worldview. A worldview in which machinery was expected to justify repair. And that worldview leaves a mark on the imagination. It is why people still chase old American inline sixes and truck V8s. It is why certain diesels still command almost spiritual respect. It is why there are engines whose names still start arguments in workshops, on farms, in garages, and across generations. Not because they were all perfect, but because enough of them proved the same point over and over again. Build with margin. Build with seriousness. Build like the engine will be asked to suffer. Build like the owner might not always be ideal. Build like repair is part of the future, not an embarrassment. Build like durability itself is a form of dignity. That is what the best American engine builders understood. And perhaps that is why the most indestructible engines feel so important now. We live in an age increasingly dominated by optimization, efficiency targets, packaging compromises, emissions complexity, software dependence, fragile tolerances disguised as innovation. Much of that progress is real, and much of it is necessary, but it also creates a quiet hunger for machinery that feels more absolute, more forgiving, more overbuilt, more physical, more honest. That hunger is why people still romanticize old iron blocks, simple layouts, heavy castings, and truck-derived power plants. Not because they want to return entirely to the past, but because they recognize a missing value when they see one. Mechanical confidence. The confidence that says, this machine was not built to impress you for a brochure cycle. It was built to outlast your assumptions. And in the end, that is the true meaning of million-mile iron. Not simply engines that accumulate absurd mileage, but engines that reveal a philosophy in which durability is not accidental, a philosophy in which strength is allowed to be visible, a philosophy in which engineering serves long use, not short applause. That is why these engines remain so respected. Because they did not merely power vehicles, they carried generations. They pulled families, tools, work, freight, memory, and livelihood across landscapes larger than many countries. They woke before dawn, they idled in snow, they hauled in summer heat, they accepted abuse, they returned after repair, they outlived paint, seats, owners, and sometimes the bodies wrapped around them. They stayed. And when an engine stays long enough, it stops being a component. It becomes a witness. If mechanical endurance still means something to you, subscribe to Timeless Treasures and tell me which American engine you trust most to outlive everything built around it.